Hello everyone. Today we are going to do the second part of the topic magnetism. So we will be addressing the following questions. How does a magnetism take place? Can a magnetic substance behave like a magnet? How can you care or store magnets? And can magnets lose magnetism? So these are the basic topics that we will be going through today. First, first comes the magnetic field around the magnet. So in our previous video, you would have seen that we have studied about the different magnets, what are different magnetic substances. But have you ever thought how does this magnetic work or how does this magnet work? So the magnets work around magnetic field. So a region around a magnet where its influence is felt is called as the magnetic field of the magnet. See here, if you can see, this is a magnet, a bar magnet that I have taken here, and these are the lines which we call as a magnetic field. But can we see this magnetic field or magnetic lines? No, we cannot see these magnetic lines, but they are represented by means of these set of curves 1, 2, and so on. This you can find around a magnet, and these are called as a magnetic field lines or magnetic lines of force. Now, how do we know then? How did we get into this conclusion that these kind of magnetic lines are present in a magnetic field? So you can do a very simple activity at your place. You can take a magnet, a bar magnet or any magnet you have, and above that you can place a plain A4 sheet, and on top of that you can place the iron particles, very fine iron particles that you can place it on top of the white sheet. And when you rotate the magnet, these iron particles will get aligned in something in this kind of a format. So do this activity and let me know in the comment section, and do write a review for us. Thank you. Going further, the properties of magnetic field lines. So now we just saw the magnetic field lines. Now what are the properties that we could draw from that? So the lines start from the North Pole and end at the South Pole of the magnet. So if you see this, it starts from the North Pole and it ends at the South Pole. So you see the arrows here, the direction of arrows. Next, we are crowded at the poles where the magnetic field is the strongest. That was the property of magnet that we studied. Yes, so they are crowded at the poles, whereas it's minimum towards the other places. Next, these lines, if you see, they do not intersect each other. They were all parallel to each other. They were not intersecting at any point. Okay, and also each line, if you see, it is a closed continuous curve passing through the magnet. It's a curve shape and it is continuous. You cannot see that half line here and it is incomplete. No, right? So it starts from the North Pole and it ends at the South Pole. It is a complete and continuous curve that we could see. Next, electromagnet is a piece of magnet. Now, these were all about magnetic field lines and magnetic properties. Now, what about electromagnet? When we talk about electromagnet, so electro, the name itself suggests that it is something which is related to electricity. Okay, so electromagnet, what is that? So it is a piece of magnet covering the current carrying wire. It remains a magnet only as long as the current passes through the wire and loses its magnetism when the current is switched off. There are two things, a magnet is there and the magnet. Around that magnet you have this current carrying wire, a normal wire which is being run around it, and that wire is attached to an electric supply. The moment you switch on that electric supply, the current starts passing through that. Okay, and when you switch it off, you can find that there is no current that is being flow, or basically there is no magnetism that you can find there. It loses its magnetism when you switch off the current. Going further, there are two types of magnet. One is a permanent magnet and other is a temporary magnet. So as the name suggests, permanent magnet is the one that retains very important, retains its magnetic properties for a long period of time. And few examples that I have here are iron, nickel, cobalt, and some rare earth alloys, which act as permanent magnets. Next, temporary magnets. As the name suggests, it's temporary, right? So temporary magnets are those that act like permanent magnets when they are around a strong magnetic field or when they are kept around the strong or permanent magnets. So they will act or they will behave like permanent magnets. But they will lose their magnetism once they are away from that magnetic field. What do I mean by that? So when I keep any temporary magnet or any item with a permanent magnet, so they will also act like magnets or they will behave like magnets. But the moment I remove this magnet, these substances which were earlier behaving like temporary magnets will lose their magnetism. Now you may ask here, like, how can we know, like, all the substances, if we keep with magnet, do they behave like temporary magnets? No. So there are certain items, just I've given you some examples like paper clips, iron nails, and other similar items are the few examples of temporary magnets. Now you have to let me know in the comment section, like, what other items can behave like temporary magnets. This is an assignment for you. Going further, so these are the two types of magnets, permanent and temporary. Going further, now, how do we store and care magnets? Yes, we know that magnet has these properties, magnet has these abilities, but you need to know how to store and how can you care for that magnet. So a magnet gets demagnetized. What do I mean by demagnetized? That means the magnetic property is removed when it is left by itself for a long period of time. When you keep it at one place and you are not touching it at all, so it may lose its magnetism. And the other rules which you should follow. Okay, you should not drop the magnet from a height. If you drop it, it may lose its magnetism. If you heat a magnet, it will lose its magnetism. If you hammer a magnet, hammering also leads to the removal of the magnetic properties done by magnet. And also, you should keep certain items such as the DVDs, debit cards, CDs, audio and video cassettes, the credit cards, ATM cards, and the mobile phones, which contain magnetic material, away from the magnet to prevent damage. So we generally observe this whenever there is any magnet, and when any of these items are around, it gets stuck to the magnet. So these items, but they are actually in the process, the magnet which is there, it is getting damaged and it is also losing its magnetism in the process. Let's go further. What are the different uses of magnets? We know we use it as stickers. Yeah, magnetic toys, most of the toys or any toys that you see that has got magnet, there are magnetic toys. Then refrigerator doors, you can see that there is a slide. When you keep something, there is a slight magnetic field that you get in the refrigerator doors. Yeah, because even the refrigerator doors are made of magnets, a little bit. Then making magnetic compasses that we saw earlier in the first slide, that the sailors and navigators used to find the direction. And also for separating iron from the ores that contain other non-magnetic substances. Or basically, if you wanted to separate iron from other magnetic substances, you can use magnet. Next, removing tiny iron particles that accidentally entered into a patient's eye by an eye doctor. So if by any chance accidentally this may happen, that the iron particles, when you're playing or something around, it may enter your eye. So to remove that iron pieces from the eye doctors use these type of magnets. So these are few uses of magnets. Going further with the demagnetization, we just mentioned in previous last to last slide about demagnetization. So demagnetization means removal of magnetic properties. How does this happen? There are three ways how the magnet may lose its magnetic properties. One is by heating or hammering, and the third one is by electricity. Now, if you heat a magnet, what is happening? When you heat a magnet, not just heating, to a certain temperature which is called as a Curie point. At that time, the energy which is present in the magnet, in the magnetic dipoles. What do I mean by dipoles? There are two poles in a magnet, and hence I call it as dipoles. From their ordered orientation, they will change. The energy will keep changing. And you know, when the energy keeps changing, the particles will be here, they will not be aligned in that proper, correct manner. Okay, their orientation changes. And the the range of order that we saw, the way the magnetic lines are arranged or the magnetic field is arranged, that gets destroyed, and hence there is little or there is no magnetization which is there in that particular magnet. Okay, it has lost its magnetic property. So the temperature required to achieve the effect is a physical property of that particular material. You have to heat to that particular temperature, only then that the magnet will lose its magnetism. The next one, hammering. Same thing happens when you keep hammering the magnet. The same thing, the particles will get energy and they will start to disorient themselves. Okay. The next is by applying pressure. When a particular magnet is applied pressure, the same thing happens. The energy gets disoriented, and also if you're dropping it on a hard surface, the same thing happens. Okay, so you need to be very careful how you deal with magnet. So physical disruption and vibrations shake the order out of the material, thus demagnetizing it. So these are few ways how you can demagnetize the material. This is a link that I wanted. You can do a quick summary of the research that you can do on the history of magnets. What you can do is just go to Google, go to a good site, and from there, an authentic site, any research journal, from there pick up how did humans or how did we come to know about these magnets. So do a research about the history of magnets. With this, we complete the topic magnetism. Hope you enjoyed the class. Hope you enjoyed the session. And if you have any queries or anything, do let me know in the comment section and I will make a video or will refer to you accordingly. If you did not subscribe to our channel, quickly subscribe to our channel. Thank you.